Hi everybody, this is the Advanced Algebraic Pre-Calc video, the first video on complex zeros and the Fundamental Theorem of Algebra. In this video, we're going to focus on the Fundamental Theorem of Algebra, which you actually already know, and then finding zeros of polynomial functions and rewriting an equation in factored or linear form. We have had it in prime factorization, but we can write it if we know all the zeros in terms of linear factorization. And then I'm going to give you guys some zeros and we're going to come up with some equations. And that'll be the end of video 1. So a lot of this is going to seem like other things we've done. 2-3 is finding all zeros when you can factor. 2-4 is finding all zeros when you can factor or when you can't factor and then you find one using your calculator. And then 2-5, you could get some complex zeros because you could use the square roots. You could get imaginary zeros. Just those things could happen. Okay, all this stuff kind of works together. So it's like 3 sections that are kind of very similar. So my first group of questions is going to be how many zeros could the following have? All right, so my first one is f of x equals 3x to the 4th plus 2x squared minus 1. And we'll just throw a second one in here. F of x equals x squared plus 3x plus 1. All right, so zeros are x-intercepts. So how many zeros could they have? Well, in the first one, if I had x to the 4th, that would indicate I could have 4 factors. If I could have 4 factors, there could be 4 zeros. Could there be less than that? Yeah, because we could have a double root where it touches and turns, or we could have imaginaries that don't even exist. All right, and then in number 2, how many could we have? Well, this is a quadratic. There could be 2 zeros. Again, there could be less than that. There could not be more because if it's 2, that means we have factors of an x time or an x term times another x term. All right, so I know we've done that before. This is just the fundamental theorem of algebra. So this just illustrates the fundamental theorem of algebra. And this just says that a polynomial function of a degree n has n number of zeros, okay? Has at most, I should say, n number of zeros. Those are real, unreal, and some of them might be repeated, all right? So a polynomial function of degree n could have at most n zeros. And those could be real, imaginary, integrals. They could be integers. And they could also be rational or irrational. Remember, irrational numbers are square roots that do not you can't find them in the head. So like an irrational number would be like the square root of 5. Square root of 5 is irrational. All right, so that's what we've talked about before. All right, so now linear factorization theorem. I'm just going to get these out of the way right away. Okay, linear factorization theorem just says that any polynomial can be written as a product of its factors. And I'm going to say linear factors. Okay? Now, even if we have something squared, we can actually come up with what those linear factors are going to be. Okay? So what they say is, this is kind of the math way of defining it. You'd have your A, which could be your stretch or your vertical stretch or your vertical compression. And this would be x minus, they say it's z sub 1, x minus z sub 2, all the way down to x minus z sub n. And that'd be where z sub 1, z sub 2, and all of the other ones up to z sub n are zeros. Okay, and we'll get to all those. We've done those before, and I'll even take some things and I'm going to rewrite them, okay, as products of linears. Okay, it's not going to be a big deal. All right, so what I wanted to do is I just wanted to start out by looking at things that we've had before. We're going to start this video out by not only looking at this stuff, but also first solving some things. And then after we solve them, we're going to go ahead and write some equations given some zeros. The second video is going to be a little review of this, okay? So my first is going to be find all zeros and rewrite the polynomial as a product of linear factors. All right. So this was our how many zeros. That could be our question number 1. This is going to be question number 2, and this is going to be A. All right. So here we go. First one, we're going to solve find all the zeros for 0 equals, let's go with x cubed minus 5x squared. Sorry about that. Plus 2x minus 10. All right, we're going to find all those. Now, looking at this, what you guys can do, there's 2 ways you can look at it. I could say, can I factor this? Which I would try to factor it by grouping. Or can I use my calculator to find a 0 and go from there, like I did in the last section? I can totally do that. But I'm looking at this, and I feel like I can factor by grouping. And factoring is a lot easier than getting my calculator out. So x cubed and 5x squared, this is going to have an x squared in there. So it's going to be x minus 5. Keep in mind, I want this to be x minus 5. If I take a 2 out of here, a positive 2, that gives me 2x minus 10. I'm feeling good about that. So I'm going to factor out the x minus 5 from each, and I'm left with an x squared plus 2. That equals 0. Now, here's the deal, you guys. If I'm writing it as a product of prime factors, I'm done because I can't factor x squared plus 2 anymore. But I can rewrite it as linear factors, and I will get to that in a second. But in order to do that, I have to find my zeros. So I know one of them is at x equals 5. So if you went to your calculator and you did the synthetic division thing, you would just find one at 5. Okay? Then the next thing is that I'd have to solve x squared plus 2 equals 0. Well, I'm going to subtract 2. So x squared is going to equal negative 2. Takes the square root. X is going to equal plus or minus. All right, we're going to take an imaginary out. Plus or minus I times the square root of 2, right? So my zeros would be 5. And then an I times the square root of 2, and negative I times the square root of 2. Now, a couple things here before I get to my linear factors. First off, do you guys notice that the only time I ever get imaginaries is when I'm using the quadratic formula, or I'm taking a square root and I pull out an I? Well, that's where I'm getting 2 answers. Imaginary solutions are always in partners. They're never single. They're always part of a couple. You know those people. They're always part of a couple. Well, imaginaries are always a part of a couple. And so they always have to have a partner. All right, so keep in mind that always has a partner. It's going to be super important later. Now, as far as me writing this as a product of linear factors, I know I'm getting kind of crunched here, but this 5, wouldn't that give me an x minus 5? Now, all the other factors would be the same. This was x minus 5. This is going to be x minus I times the square root of 2. And this guy would be x minus a negative I times the square root of 2. But this guy, I'm going to have it as x plus I times the square root of 2. So I'm going to kind of circle these. I have a blue marker here. These are my factors. These 2 and then that one. Okay, so that would be the product. So on a homework, what you do is you just say, okay, it's this times this times this. There you go. There's my product of linear factors. Because they are linear because they all start with an x. I'll make the next one look prettier, okay? All right, so that's my first example of just finding some zeros. All right, I'll try to keep these things organized. Here we go. Here's another one. Yep. Find all the zeros for. So this is B. All right. Y equals x to the 5th plus 4x to the 4th minus 9x cubed minus 44x squared plus 72. All right. Now, I want to find all the zeros, so by the fundamental theorem of algebra, I should be able to find 3 of them, right? We should find 3 of them. I'm sorry, 5 of them, my bad. My hope is to find 3 real ones, because if I take out 3 real factors, I should be left with an x squared. Then I can actually factor, or I can use the quadratic formula. So that is my ultimate goal here in finding all of these zeros. Okay, and we'll have one more of these where we find all the zeros in this video. All right, so this one's too big, and I can't factor it. So here we go. I'm going to get my calculator out, and I have x to the 5th plus 4x to the 4th minus 9x cubed. There we go. Minus 44x squared plus 72. Okay, so I have x to the 5th plus 4x to the 4th. Hopefully you can see that. Minus 9x cubed minus 44x squared. Ooh, did I do that okay? Yeah, I did. It's not supposed to have a linear term. We're good. All right. Looking here, it looks like I like to keep track of my x-intercepts, because we're going to find all the zeros for this, and we'll find the prime and a linear factorization. That way you have both of them, because it really doesn't take much to do the linear factorization, you guys, after you find your zeros. All right, my zeros, there should be 5. I have one of them at, 3? And I can check if there's a double root there. Oh, that seems like it's getting super big. I got another one at -2 and -3. That hopefully is enough. I'm going to do a zoom 6 and see if they pass through at 3, -2, and -3. Oh, that touches, and it looks like it might touch and turn there. We shall see. Right, because one of them, it kind of looks like it could touch and turn, but we'll see what's happening. That could just be like super close to being on the top there. And if I want to take a look, because I'm always curious. Let's do a zoom box 1. We're going to go to that -3 and see what's happening here. Is it touching and turning, or is it... Oh, let's do there. And there's my 3 right there. Yep, it passes through right there, and it's going through right there. So it is going through 3, so there's another one in there. All right, let's do a zoom 6, and we're back to where we were. So there is, looking at this, there's 1, 2, 3, 4, 5. All right, so there's 5 of them that we should be able to find. Those are my first 3. All right, so first thing I'm going to do is, let's go in order. I know I can have a prime factorization. I'm going to write this up here. So it's y equals, we would have x minus 3 times x plus 2 times x plus 3. Now I need to figure out what comes after that, after I do all of my work within this problem. Okay, guys? All right, so I'm going to start with x minus 3 should divide evenly in there, so I'm going to start with my box and go with 3. I'm going to have a 1, a 4, a -9, a -44. Then I'm going to have a 0 because there is no linear term there, and then a 2. And in class, I've been really big on what should happen. My remainder should be 0. So I should be able to whip through this, and if I make a mistake, I always go back. 1. 3 times 1 is 3. Add down 7. 7 times 3 is 21. Add down, that's like 12. 3 times 12 is 36. Add down, what's that, negative? It's not -12. Oh, my brain. 36 minus 44. Is it? No, it's 8. Oh, 8. 3 times 8 is 24. Add down, that's 24. 3 times 24, I'm hoping, is 72. Oh, my bad. I knew I was gonna get something too big here. This should be -8. This should be -24. This should be -24. 3 times a -24 is -72. Then you drop down at 0. All right, so if you wanted to, it'd be remainder constant x squared, x cubed, x to the 4th. So this would be like x to the 4th plus 7x cubed plus 12x squared minus 8x minus 24. That's super unnecessary, because now we're going to take the next one and factor it out. So let's take the x plus 2 out, so then a -2 goes in here. We would not use the original guy, because if I did, my bottom line would be an x to the 4th, and I need to make it smaller. So if x plus 2 is a factor of the big guy, it's going to be a factor of the little one. 1, 7, 12, -8, and -24. Okay, here we go. Drop the 1. 1 times -2 is -2. This would be what? 7 minus 2 is 5. -10, add down 2. 2 times -2 is -4. Add down -12. -12 times -2 is 24. That's 0, which should happen. So again, remainder, constant x squared, x cubed. If you want to, it's x cubed plus 5x squared plus 2x minus 12. That means now we got to do the last one, which would be a -3 in there. And again, we're using this guy, not the big one or the other one, because I need to break this down into its prime factorization, or its product of linear factors. All right, so here we go. My sun is kind of getting really crazy right now. So I'm going to have a 1, a 5, a 2, and a negative 12. All right, drop the 1 down, negative 3. Add down, that's 2. 3 times negative 2 is negative 6. That's negative 4. That's 12. That's 0. It's going to be x squared plus 2x minus 4. All right. So then the next thing I would try to do, you guys, was to see, okay, can I factor this? And there are no factors of 4 that add or subtract 2. Therefore, I am going to complete the square, okay, because I want to find the other 2. So I've got an x squared plus a 2x minus 4 equals 0. I'm going to add 4. X squared plus 2x, this is going to equal 4. Remember, I want to get something times something, which is something squared. Where's my, I need a different colored pen. So this is going to be an x and an x. To get 2, we're going to have 1 and 1. Let's go plus and then plus. That means I need a plus 1 here, right? So if I add 1 here, I have to add 1 there. So I'm going to have x plus 1 squared equals 5. Take the square root. Subtract 1. Oh, that should be plus or minus the square root of 5. X equals negative 1 plus or minus the square root of 5. So this is going to be, next one is negative 1 plus the square root of 5, and negative 1 minus the square root of 5. Those are mine, okay? So my prime factorization, you guys, would be x minus 3, x plus 2, x plus 3, and then I'm going to have an x minus this guy, which would be negative 1 plus the square root of 5, and then the other one would be x minus negative 1 minus the square root of 5. Now, the other thing we could do is you can distribute this through, and this could change to x, and this would be plus 1, and then minus the square root of 5. That's the same thing. And I could distribute this through. This would be x plus 1, and then plus the square root of 5. Either one is fine. I'm not super picky with how you do it. All right, so that is that. Now, kind of looking at this and finding them, all of these factors, or all of these zeros are real, you guys. There's one at 3, there's one here, and there's one at positive 3 as well. This guy right here, I'm assuming it's the negative 1 plus the square root of 5, and over here we got negative 1 minus the square root of 5. Well, negative 1 plus the square root of 5 is about 1.23. Negative 1 minus the square root of 5 is about negative 3.23. All right, so if I want to look at those and just check them, to look at this guy right here, I'd go second trace, find a 0. Where are we at? I'm at 63, and I'm way up there. There we go. Enter, enter, enter. Right, there's my 1.23. That's this guy right here. And then I have to find the other one over there. I don't think I'm going to be able to find it, but I'll see. I may have to zoom in. I can find it. I just don't know if I can zoom in. Where are we here? Here we go. And so I have to go to the left and then to the right. Oh, I think I'm going to get it. Yep, because it was just below and under. And negative, this should be the negative 3.23. All right, so that's it. So that's that one. My sun is going to get kind of weird, so I apologize. It might get kind of bright in some parts of this. All right, so that's it for finding all those zeros on that one, which is great. It took a lot of time, but I told you guys in class, I get really excited about these things because I really enjoy these. All right, same thing. That was which one? That looked like I gave it, what? B. This is C, and then we're going to move on to the last thing in this video. Okay, same thing. Find all the zeros and do the linear factorization for, we'll call this guy g of x equals, let's go with x to the 4th plus x cubed plus 6x squared minus 4x minus 40. All right. Now, again, how many zeros should I find? I should find 4. I could find 4. And how I'm going to find those. So the first thing I'm going to do is I'm going to get my calculator out. And here we go. I'm going to go with x to the 4th. And then plus x to the 3rd. Plus 6x squared. Minus 4x. And then minus 40. All right. I am just going to look at this and label my zeros. It looks like I have one at negative 2. So x is going to equal negative 2. That's one of them. There could be 4. I'm curious if there's any more over here. Yep, 2. All right, and then I'm willing to bet I'm not going to catch too many more, but if I look at the graph, I just want to see if it's touching and turning or passing through at those. Looks like they're passing through. So I'm going to have 2 real at negative 2 and 2, and then 2 probably imaginary ones, but we'll see how that goes, okay? So that's all that I needed my calculator for. As far as me writing this as a factor or a product of linears, this x minus 2 came from an x plus 2, and the 2 comes from a factor of x minus 2. So what I need to do is I need to figure out the other 2 that would be here. That would give me the other 2 solutions. So first I'm going to start with a negative 2. So I'm going to break this down into factors. So x to the 4th was a 1, and then I have a 1 with the cube, I have a 6 with the square, I have a negative 4 and a negative 40. Again, since these are zeros, we should have a 0 here. Drop the 1, negative 2, negative 1, this is 2, 8, negative, 16, this is going to be negative 20, and that'd give me, 40, and 0. Great. Remainder, constant, x squared, x cubed. If you wanted to do this, this would be x cubed minus an x squared plus an 8x minus 20. That's not necessary because we're going to now take this guy out, which should be a 2. And again, we are not using the one on the big guy because that would just divide it out from the beginning. It'd be like saying, let's do a prime factorization of 100. Okay, let's change that to 2 times 50. All right, so then I made it 2 times 50. What else could I make it? Well, you break down the 50. You don't change it to 4 times 25. You just keep kind of dividing things out. All right, across the bottom, 1, negative 1, 8, negative 20. Okay, drop the 1. 2 times 1 is 2. Add down 1. 2 times 1 is 2. Add down, that's 10. 2 times 10 is 20. That's 0. I got an x squared plus an x plus 10 left over. Factors of 10 that add or subtract to 1, they don't exist, so I can't do that. So this is going to be equal to 0. If I wanted a prime factorization, this guy would go here. For a linear factorization, I need to have linear factors. So everything has to start with an x. All right, guys. So here we go. This one, I'm going to use the quadratic formula. My a is 1, my b is 1, and my c is 10. I know the numbers are small, but my b value is not even, so I don't want to worry about using completing the square. So x is going to equal, the opposite of b is a negative 1, plus or minus the square root of b squared. 1 squared is 1. Minus 4 times a times c. A is 1, c is 10, that's 10. All over 2 times a, 2 times 1 is 2. So x is going to equal negative 1 plus or minus, this is 2. All right, let's look at what's going on in here, you guys. So 1 squared is 1. Negative 4 times 10 is a negative 40. So 1 minus 40, wouldn't that give me the square root of 39? Negative 39, my bad. Now, 39 is just 13 times 3, so I don't have a perfect square I can take out. But the only thing I'm going to do is take out that imaginary. So x is going to equal negative 1 plus or minus I times the square root of 39 all over 2. So my other zeros, you guys, are negative 1 plus I times the square root of 39 over 2, and negative 1 minus I times the square root of 39. Probably make this smaller so I can actually fit them all in there, right? All right, and then, so this is going to be, all right, so I have negative 1 plus I times the square root of 39 over 2, and negative 1 minus I times the square root of 39 over 2. Okay, as a prime factorization, the easiest way is just to say x minus this guy, which would be negative 1 plus I times the square root of 39 over 2. And the other one would be x minus, and then a negative 1 minus I times the square root of 39 all over 2. Now, when you get to your homework, they may actually distribute the negative through. I'm not going to worry too much about that here. All right? So those are 3 problems by just finding your zeros, all right? And that's all the ones I believe I have for this video on that. Okay, the third part of this video, what we're going to work on is writing equations given the zeros. Okay, we're going to write equations just given the zeros. And then the next video, we're kind of do a little hodgepodge of everything else. That's good. Okay, so A. I'm just going to give you the zeros. Let's say they're at x equals 3 and x equals negative 5. All right? So if they're at x equals 3 and x equals negative 5, what gave me the 3? That'd be x minus 3. What factor gave me the negative 5? That'd be x plus 5. That equals your y. So my equation, I'm going to go through and multiply this through. X times x is an x squared. X times 5, that's a 5x. Negative 3 times x is a negative 3x. Negative 3 times 5 is negative 15. Combine your middle terms, you get x squared plus 2x minus 15. All right, and to make sure that that works, you can always graph it, or you can put the equation in here. X squared. Ooh, I feel like I'm getting dark here. X squared I wonder if I can turn on. Nope, I can't turn on the flasher. So I'm going to have x squared plus 2x minus 15. And if I look at my table, I should be able to see zeros of 3 and 5, right? 3 and negative 5. So I think I see 3 there. Yep, and negative 5. I'm going to turn on the light behind me. All right, or above me. See if I can get a little extra light in here. I apologize. It's the afternoon. Things are getting a little shady on me, but not that shady. All right, so that's that one. All right, so my next one. Okay, this is B. This one was a little different. I said x equals, let's say x equals 3 has a multiplicity of 2. And then the other one is negative 1. All right, so we need to come up with what this is going to look like too, right? Okay, so for this one, x equals 3, wouldn't that come from an x minus 3? Now the multiplicity is 2, so that'd be squared. And that's times the one that gave me 1 would be x plus 1. So that would be factored form. So this guy is an x minus 3 times an x minus 3, and this is times an x plus 1. I'm going to multiply these guys together first. So I have an x squared minus a 3x minus a 3x. What? That's plus 9. Combine those, we get x squared minus 6x plus 9. I'm going to multiply that by x plus 1. So taking the x through here first, I'm going to have an x cubed minus a 6x squared plus a 9x. And taking the 1 through, I'm going to have an x squared minus a 6x plus 9. Here we go. X cubed minus 5x squared plus 3x plus 9. That equals y. So I could always graph this thing too. Sorry, I'm trying to keep it so there's not too much of a glare because the sun is in and out. So if I wanted to put this in my calculator and make sure that I had zeros at 3 and negative 1, I should be good to go. All right. All right. Now, before we get to the big ones, because there are some that are pretty nasty, and I got 2 of those, because we haven't looked at what if my zeros are imaginary. What do I do there? I want to do a little bit of a little review here. So we're going to take a little break from this, and we'll look at C in just a bit. We're going to look at, this would be the 4th thing for this video, find the equation given these linear factors. All right, because the other ones we could have done even without this section, but we haven't done anything with imaginaries. All right, so let's just say that this would be my linear factorization. Let's say it was, what, x minus 4i times x plus 4i times an x minus 5. All right, and that was my linear factorization, and I'm like, hey, I want you to figure out what the equation was given that linear factorization. Well, here's the deal, you guys. I don't like i's. Our equations should not have imaginary parts in them. Therefore, what I have to do is I would highly suggest you multiply your imaginaries first, okay? You're going to multiply the imaginary parts first, and then multiply it by this last, okay? And if that doesn't work, there's another trick that we're going to use for the next group. All right, so here we go. An x times an x is an x squared. An x times a 4i is a positive 4ix. A negative 4i times an x is a negative 4ix. And a negative 4 times a positive 4, or negative 4i times a positive 4i is a negative 16i squared. Now, going back to what we just said about imaginaries, I squared is a negative 1. So since I squared is a negative 1, wouldn't this change it to plus 16? The 4i's are gone because they cancel each other out, and we get x squared plus 16. That needs to be multiplied, you guys, by x minus 5, and that'll give me my polynomial. X squared times x is an x cubed. X squared times a negative 5x squared is a negative 5x squared. 16 times x is 16x. And 16 times 5 is going to give me, what, 80? And it's minus 80. And I'll double check. 16 times 5 is 80. All right? So that is what I got there. Now, you can rewrite things as linear factors if you want. So going back to this stuff here, this is going to be C. Okay? Let's say that my zeros were 7, negative 2i, and positive 2i. And now I'm giving you those. if I wanted to, I could reset this guy up just like I did here as a product of linear factors and go from there. Or I can do what I did, or I can do this other thing. And I'm going to do the other thing. All right, so let's think about it. Negative 2i and positive 2i. I really don't even need the plus here. Now, that makes sense because if I'm trying to find zeros, they have to come in pairs, right? Those imaginary parts in the square roots have to come in pairs. So I know in the end this was x equals negative 2, or this is plus or minus 2i, right? Because these two would have came from x equals plus or minus 2i. All right, so then the next thing that I would do is we don't want i's anymore. So what do we do to this equation so we don't have imaginaries? Well, imaginary, if I square it, it's gone. So I'm going to square both sides. I'm going to have x squared equals. All right, plus or minus squared, that's just going to give me a positive, so I don't have to worry about that. 2 squared is 4, I squared. Well, isn't I squared a negative 1? Well, this would be x squared equals 4 times a negative 1 would give me negative 4. Add 4. That gives me x squared equals 4, which makes sense, or x squared plus 4 equals 0. Because if I solved x squared plus 4 equals 0, wouldn't I subtract 4? X squared equals negative 4. Take the square root. Isn't the square root of negative 4 plus or minus 2i? So then I'm going to take that guy, and I'm going to multiply it by the 0 I would have gotten from that, which would be x minus 7. And we're back to what we kind of did up here. X squared times x is an x cubed. X squared times a negative 7 is a negative 7x squared. 4 times an x is a 4x. 4 times a negative 7 is a negative 28. And that's what y would equal, and that would be my equation. All right, so finding giving zeros and finding my equation from there. All right. All right, I have 2 more for you guys, okay? They get a little more complicated. So that was C. Here's D. All right, and hopefully the sun will cooperate because it should be going down soon. All right, for D. Here's your equation. Let's go with, we're going to have a real 0 because you always have to have at least one whenever I do tries. Let's go with 6. I have 6, and then I'm going to have, let's go with 3 plus I. All right, here's the thing. I only gave you 2 zeros, but there has to be 3. You know why there has to be 3? Because you cannot have an imaginary. An imaginary has to have a partner, right? So it should be understood that 3 actually, the 3 plus I had a partner of 3 minus I. These have to come together, okay? So here we go. X is going to equal 3 plus or minus I, because that's what both of those would have been in the end, and we would have separated those out. All right, so here we go. The goal is to change it so with the i's by itself so I can square it and make it into a number. Problem is I have to subtract 3. All right, so I'm going to subtract 3. So I have x minus 3 equals, this is plus or minus I. All right, now I'm in the point where I can square things.